Okay, this is Dr. Williamson going over part 2 of the molar volume of nitrogen lab. In part 1, we found that the volume went from 2.2 milliliters down to 34.6 milliliters. And we calculated from the grams of sulfamic acid, we calculated the moles of nitrogen produced was 0.001545 moles. The volume was 0.0324 liters. So in this particular example, the molar volume rounds to 21.0 liters per mole when I go 3 sig figs. Okay. Now, when the water levels are equal, that means that the pressure from the atmosphere pressing down, now that should be an open container, but the pressure from the atmosphere, the barometric pressure, should be equal to the pressure of the nitrogen pushing the water down, plus the pressure of the small amount of water vapor that's in there too. It's called the vapor pressure of water. So the barometric pressure will be equal to the pressure from the nitrogen plus the vapor pressure of water. Rearranging and solving, the pressure of the nitrogen is 762.8 millimeters of mercury. I got that in the previous problem. I said the barometric pressure was 762.8 millimeters of mercury. I looked up the vapor pressure of water at 20.3 degrees Celsius, and that's 17.8 millimeters of mercury. That gives me the pressure in the lab is 745.0 millimeters of mercury. That's the pressure of the nitrogen gas. Using the combined gas law, the pressure of the nitrogen gas under lab conditions times the molar volume under lab conditions divided by the temperature under lab conditions will be equal to the pressure times the volume divided by the temperature, all under STP conditions. I want to know the volume under STP conditions. I rearrange and solve for volume for STP. STP is the temperature of STP is 273 Kelvin. The pressure of STP is 1 atmosphere or 760 millimeters of mercury. The pressure under the lab conditions was 745 millimeters of mercury. The molar volume under lab conditions we found was 21.0 liters per mole. And the temperature under lab conditions was 293.3 Kelvin. Rearranging and solving, I get a molar volume of nitrogen under STP conditions of 19.2 liters per mole. The true value should be 22.4 liters per mole. So what I'm going to do now is calculate the percent error. First, I'm going to erase this stuff. And that gives me room to calculate percent error. And the percent error, I'll go percent E, will be equal to the absolute value of the true value, 22.4 liters per mole, minus 19.2 liters per mole, divided by 22.4 liters per mole, all times 100. And my units all cancel out. So I'm going to go 22.4 minus 19.2. That gives me 3.2. Take absolute value, which is 3.2, divided by 22.4. Multiply that by 100. And I'm going to get my percent error here was 14.3% error, which is kind of large. But, that's what I got in my makeup example. Okay, that's part 2. I hope that helps explain it. I don't know if I don't think the audio is any better. I've got to get a different headset. Okay, then, bye.